Hey everybody! In today's lesson, we're going to learn how to do an exponential regression. So remember, we've talked before about how to do a linear regression for a scatter plot. Well, this time we're going to talk about how to get those exponential regressions. So sometimes the data in your scatter plot looks like it would be an exponential function would be the best fit. So we're going to use Desmos again today, but this time we're going to use it to find exponential regression equations. So let's start off by looking at this sheet. So the very first part is asking us to predict which type of regression to calculate, either a linear or an exponential. Because you can tell Desmos or your graphing calculator to find the linear equation for any scatter plot, even if the data looks like it's going to be exponential. On the flip side, you can ask Desmos or a graphing calculator to find a exponential equation for data that looks like it should be linear. So you have to know which one would be the best choice. So looking at number one, that is an example of an exponential equation, right? Or an exponential function. So we're going to, let me change that. We're going to write exponential next to that. And then number two, remember, is just a line. So that would be linear. Okay. So now we're going to go ahead and get right to it. And looking at 3 and 4, we've got tables, and we have to come up with the actual regression equation for that table. So the first thing that we're going to do is in Desmos, we're going to do like we've done before and put that data into a table. So my x's are 0, 1, 2, 3, and 4. The y's are 3, 5, 7, 9, and 11. Okay, so before I ask my Desmos to give me the equation, I need to look at the scatter plot. Does that data look linear or does it look exponential? And you can also look over here at your table. Does that table look like it lends itself to linear or exponential? So in this example, it looks like it's going to lend itself to linear. So I'm going to write linear. And I'm going to come up with my regression equation. So remember, I'm going to hit the plus sign, f of x, and this is going to be y sub 1, because this equals mx plus b, but we want that squiggly, mx sub 1 plus b. Okay, and so our linear regression equation, I'm going to write that down now. It's going to be y equals m, so 2x plus b, which is 3. Now, I want you to see that I also, and you can see on my graph here that line goes straight through those points. Well, I can also ask the calculator to do an exponential regression equation. So let's do that also. So remember the form of exponential equations? That's always y equals ab to the x power. So when I do it on Desmos, that's going to be y1, not equals, but the squiggly. And then we said a times b to the x power. So I'm hitting that AB button to get the exponent. I'm going to hit x sub 1 there. Now, look at that black line. So there's that black line that we can see, and it does kind of follow my data, and it gives me the value for A and the value for B. But obviously, the exponential equation isn't the best fit for this. It definitely lends itself to the linear regression equation. So we're going to keep our answer as y equals 2x plus 3. And it, as a linear is the best choice. All right, so that's it for number 3. Okay, so now we're going to get ready to look over here at number 4. So first we have to determine, is it better for it to be a linear, or is it better for it to be an exponential regression? Okay, so first thing that I'm going to do is I'm going to go ahead and type that data into the table. So my x's are 0, 1, 2, and 3. And then my y's are 2, 10, 50, and 250. Oops. Okay. Now, if I look at the data on the scatter plot, whoa, it's really going to be hard for me to look at that and to look at all of my points because it goes up so far. So that's kind of tricky, isn't it, to look and see. So what do we know about the table, though? The x's are going 0, 1, 2, 3. The y's are 2, 10, 50, 250. They're actually being multiplied, aren't they? Aren't I multiplying by 5 each time? So this should be an exponential regression equation, should be the best here. So let's write exponential. Okay, and then on Desmos, remember that to get the exponential regression equation, you're going to do y sub 1, then the squiggly, and then the form is ab to the x power, or a times, I should say, a times b to the x power, and you need to have that x sub 1. So it's telling me that a is 2 and b is 5. So on my screen here, I'm going to write y equals 2 times 5 to the x power. And then that actually does get graphed, but it's really hard to see that graph here until I start, there we go, start zooming in so you can tell it's exponential. And you can see, let's look at our, the residuals. Remember when we talked about residuals in the previous lesson? So here in the exponential regression equation, it gives me the r squared. So that is going to be the residual for this, and it's 1. Remember that 1 is the best it can possibly be. So this is a perfect fit for this line, for this scatter plot rather, this data. If I asked Desmos to give me the linear regression equation, so let's type that in, y sub 1 squiggly m x sub 1 plus b. Look what happens here, okay? So my R value, so when you're looking at the linear regression, you want to look at the R value, is 0.8. So it's not as good of a fit as the exponential regression equation. So you could always test them both out too using the calculator and see which one has the better residual value. Because remember, the residual value is going to help you determine R is the correlation coefficient. That's what I should have said. But that R value kind of tells you if it's, how good of a fit it is for the data, right? So we can use those R values to kind of help us. We could also use the residual plots to tell us if our if our equation is perfect, right? All right, so that's going to be it for number 4. Let's look down here at example 1. Now, example 1, I actually want you to try and do, example 1 and example 2 on your own. And there are parts to it where you have to use your equation, your regression equation, to answer certain questions, okay? So, and I'm not going to make you do the part B here. You don't have to make the scatter plot because you can just look at that on Desmos, okay? So go ahead, let's pause the video and do example 1 and 2 now. Okay guys, welcome back. So looking over at example 1, once I put that data into my table and made my scatter plot on Desmos, it looked like linear would be the best fit for that data. So I came up with a linear regression equation. And my R value, my correlation coefficient, really helped me to see that that was going to be the best. So this is what you should have gotten for example 1. And here is example 2. So for example 2, they told us to come up with an exponential equation. So I came up with that. And I told you you could skip the scatter plot, making the scatter plot. Part C, the 26th week. So you should have substituted 26 in place of X. and it did say round to the nearest download, which would be, in this case, the nearest whole number. And then for part D, it says, is it reasonable to use this model to predict the number of downloads past 1 year? And I said probably not, because remember that I don't think the number of downloads is going to continue to be an exponential thing as things go on, because then the next new thing comes along and people start downloading it, right? So that was my opinion for part D. So D is more of an opinion question. All right, so go to the next page. Here is example 3. And for example 3, I want you to go on ahead and do example 3. You do not, well, I want you to do it on your own, so I'll circle that. You do not need to worry about making the scatter plot on here because you can look at the scatter plot on Desmos. Okay, so go ahead, pause the video, and do example 3 now. Hey everybody, let's go back and go over example 3. So for example 3, the key word in the description was saying it says it seems the rate of decrease is approximately proportional to the amount of the drug remaining. So proportional generally indicates linear. So based on that information, just a simple observation and making a scatter plot on my Desmos, it looked like linear would be the best fit. Well, then you were asked to come up with a linear and an exponential regression equation and include the R values. Now, remember in the exponential regression equation, your R value ends up, you're looking at the R squared part for that one. So what I noticed, based on that, it looks like the exponential regression equation has a stronger R value, not a whole lot stronger, but a little bit stronger because we know that if you take the absolute value of these two numbers, in other words, ignore the negative for a minute. 0.998 is going to be strong or closer to 1 than 0.985, right? So not a whole lot, but a little bit. So actually, the exponential regression equation is actually the better fit. And when you graphed the exponential regression equation and the linear regression equation, both of those follow the data pretty closely, right? So you really need to look at that R value to determine which one would be the best, okay? So since I used the exponential regression equation, we find that after 13 hours, there'd be 1.085 milligrams of drug left. Okay, so you can skip this bottom part, but the gist of this, 2 things you should have gotten out of this lesson. You should know how to get the exponential regression equation using Desmos. And you should be able to determine whether or not you should be using a linear or an exponential regression equation for a particular set of data. So again, if you've got questions, please bring them to my attention. I am happy to help. But you're ready to go ahead and turn this information in and work on your independent practice. Good luck.